In this video, we will discuss two of the most common building blocks for computer programs, identifiers and expressions. Identifiers are used to give names to things you want to use again later, such as values or functions. The rules for legal identifiers in Python are they must start with a letter or underscore, the subsequent characters may be letters, underscores, or numbers, and the third part of the rule is the identifier cannot be a Python keyword. These rules mean that spaces and special characters cannot be part of identifiers. Identifiers are case sensitive, so lowercase temp and temp with a capital T are different identifiers. Here is the list of Python keywords for Python 3. Here are some examples of legal identifiers and illegal identifiers. The common convention for variable names and function names is to start them with a lowercase letter. Constants are often in all caps, and class names start with a capital letter. Some languages prefer to use what's known as camel case for multi-word names. Camel case capitalizes the first letter of each subsequent word in a multi-word name, since we can't use spaces. The example identifier 2 points with a capital P shows an example of this. Other languages prefer to use what's known as snake case to separate multi-word names. Snake case uses an underscore to separate each word in a multi-word name. The example identifier 2 underscore points is an example of snake case. Since the Python keyword for is all lowercase, it is legal to use an identifier with a capital F, but that is generally discouraged. In this first example, we can see the proper use of an identifier where we assign the name x to hold 3 and then print it out. In the next example, we add a $sign after the variable x, and we can see that PyCharm underlines it in red. Usually, but not always, the underlining in red indicates that you've done something wrong. In this case, if we try and run it, we get a syntax error. And if we try to print the name of a variable that has not been given a value, we'll get a name error, since no value has been associated with that variable name. Do not use identifiers that match the name of built-in functions. Technically, this is legal, but then you cannot use that built-in function after doing that. Some examples of the built-in functions we've seen so far are print and input, so do not use them as an identifier. In this example, we assign x to be 3 and print it out, and that works fine. But then after we assign print equals 4, print is now a variable that's of type int instead of a built-in function. And then as you see down below, we'll get a type error because print is now an integer, and integers are not callable as functions. Expressions are used to calculate new data values. We've seen numeric data and text data. Text data is generally known as strings. In Python, strings are denoted by characters between double quotes or between single quotes. A literal is a simple expression. Examples of numeric literals are the number 5 or the number 11. Examples of string literals are hello or goodbye. Expressions evaluate to values. The expression the number 5 plus the number 7 evaluates to the number 12. The expression the string 5 plus the string 7 evaluates to the string 57. This is known as string concatenation. Names used in expressions must have a value before using them. X plus 5 is not a valid expression unless x has been previously assigned a value. This shows the error we'll get. Since x does not have a value, we cannot calculate x plus 5, and we get a name error when we try to run this program. In this example, we've assigned x to be 3 and then printed it out. And then we have the statement x plus 5, and PyCharm gives us the warning that this statement seems to have no effect. And as we see when we run it, it does not have an effect. In both cases, x is printed out as 3. If we change that to print x plus 5 and remove the other print statement, then we see the warning goes away and it prints out 3 and then 8. If we had left that last print x statement in at the bottom, it would have printed 3 and then 8 and then 3 again because x is still 3. And finally, if we change the statement to x equals x plus 5 and then print x, it will print out 3 and 8 also because now we've changed the value of x from 3 to 8 with that new assignment statement.